when I was working on this, like I said, the first thing I did was I looked for all the things that were linear. So meaning that that the constant, so this is 2, 2, 2, 2, 2, and this is 4, 4, 4. So there's something constantly happening to x and constantly happening to y. It makes it linear. 2, 2, 2, 2, 6, 6, 6, right? And all of the ones that have an L follow that pattern. And so when I know it's linear, I looked and found all the linear ones. I kind of said, okay, what's linear going on here, right? So this is a linear, and I can try to see which of these things is happening here, right? So, you know, this one's linear, and I already marked it here, so I color coded this as the orange one, and this is going up 1 for every x, and y is going up 2, so it's not particularly steep. And that's how I know that is, say, not this one, right? And it can't be this one because this is as x is going up, y is going down, so it can't be that one. This is also pretty darn steep, right? And so this is saying, you were asking before, this is saying x goes from -1 to 6, and y goes from -2 to 20, and I'm looking that it goes over 1x, and it just goes up 2 for the y. So this seems like going over 1 and up 2, that's about right, of these little ticks. So this matches here, and then when I'm looking at that, this starts here at 3, and it's this, right, this is rise over run, so that's why this has to be 2x plus 3. So this is, you know, in the form mx plus b, with m being the slope. So that's why we got orange, 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 and then linear. If I look at another linear one, we can kind of go this color, green. This one is just 2x, meaning that it's crossing at 0. So that's why this is a line. It's crossing here at 0, and it's going for every, if we look at this, for every 2, it's going over 4. So you have to think about that a little bit. That's the same as also if this is 2, or rises 4, and the run is 2, that's the same thing as it just being 2, right? Because 4 divided by 2 is 2. So, and you can go through each of the linear ones in that way. And then I kind of looked again, and oh, this is the only one that's a square root function. So I'm going to kind of see, all right, down here, I only have one square root function. And when I put in an input, I'm going to say x minus 3 and then take the square root. So as I'm looking at these table of values, and I'm looking to see, does that happen, right? If I subtract 3 and take the square root, well, that doesn't work. If I put in 3, I don't get out 8. Right? If I put in 4, 4 minus 3 is 1, the square root of 1 is 1, that's not 20. And then I kind of just look, oh, 4 minus 3 is 1, the square root of 1 is 1, that works. Let's check. 7 minus 3 is 4, the square root of 4 is 2. So I see that this square root, the only one here that looks like a square root is this one, and the table that it matches is here. All right, and then I'm going to have quadratics. So I have a quadratic, I have part of a quadratic, I can see I have part of a quadratic and part of a quadratic. So everywhere quadratics, I'm looking at x squared. So this one has to be a quadratic, this one has to be a quadratic, this one has to be a quadratic, and this one has to be a quadratic. And I start to think, okay, a quadratic that's upside down, which is only this one, has to have a negative value in front of x. So this must be here. All right, and then you can start to, this one would say, when x is 0, right, 0 squared plus 0 means y has to be 0. So looks like this is 0, 0, could be this one, can't be this one. And so then I have to see, I have to decide between here and here, right? And maybe I put in another value and see what, some values and see what happens. And that's the same thing. I have to play around with the values here. And then I just kept working back and forth. And then also, in quadratics is one more little hint. When I have this x plus 1, x minus 1, this means that when y is 0, x is negative 1 and positive 1. So, and I look here, that's what's happening right here and right here. That's the only one that has those roots. So, like I was saying, I was trying to figure out, is this one here or here? But it's got to be this one because this has to be this one. And so it's a bit of a process of elimination to kind of go through and match. All right, let me know if that helps you on the thinking with this.